Good morning, children. In previous class, we have discussed chemical displacement reactions, and these are of three types: metal displacement, metal non-metal displacement, non-metal displacement. And these are the metal and non-metal activity series. Here, activity series means the metals arranged in the order of their decreasing order of their reactivities. Now, here this is a non-metal activity series. Fluorine, chlorine, bromine, iodine. Top to bottom, reactivity decreases. In metals also same. Top to bottom, reactivity decreases. This is the position of hydrogen. And here above the hydrogen and here below the hydrogen. Your first case, metal displacement reaction. And we already discussed that metal displacement always high reactive metal displaces low reactive metal. Here, low reactive metals do not displace high reactive metals. For example, look at this. Here, copper sulfate plus iron gives rise to. Here, copper sulfate means this is a copper metal and this is a iron metal. Look at the activity series. Where is the position of iron? Where is the position of copper? If you observe the positions, iron is a top metal, copper is bottom metal. So here iron displaces copper position. That too, here displacement reactions means high reactive metals displaces low reactive metals from their aqueous solutions, from their aqueous salt solutions. Here aqueous salt means the salt which is dissolved in water, you get salt aqueous solutions. Here iron is solid. Here iron can displace copper and you get here copper plus iron sulfate. Look at this. Here the position of the copper is displaced by iron. So this is aqueous solution and here this is a solid. That means here iron comes out from the solution and these are deposited on the iron nails. So if you observe this chemical reaction, here iron, more reactive metal, it can displace copper, which is less reactive metal. Similarly, look at this zinc sulfate plus iron. Look at the position of zinc and iron. Here, the position of iron here, and here the position of zinc is here. Means zinc is a top metal, iron is a bottom metal. Here, bottom metal, iron, low reactive metal. In this case, it does not displace. That means no reaction taken place. Here, this is aqueous solution. Here, iron solid. Here, iron nails are placed in zinc sulfate solution. There is no chemical reaction. There is no displacement reaction because iron is less reactive than zinc. But in the case of copper sulfate, iron can displace copper. And we observe the color changes also. In first case, we observe color changes. Here, this is a blue in color now. Copper sulfate aqueous solution has a blue color. Here iron nails, when iron nails are placed after some days, after some time, we observe here color shading, means the color changes. Blue color turns to green color. This color change represents displacement reaction has taken place. This is metal displacement reaction. Is it clear? Next, second category what? Metal, non-metal displacement reaction. Here second type metal, non-metal displacement means here metal which is high reactive metal. Here non-metal means that is always hydrogen. Most of the cases hydrogen. So here metals displace hydrogen from cold water, hot water, dilute acids, or concentrated acids. Here metals, hydrogen can displaced by here metal. Hydrogen displaced by the metal from water, whether it is cold water or hot water. Hot water means that is nothing but steam. Here are acids, whether dilute acids or concentrated acids. If you observe the activity series, we can understand these are high reactive metals, moderate reactive metals, low reactive. How can we understand this? Based on these reactions now. The meaning is here the metals which are up to calcium. Remember these points here: potassium, sodium, calcium. These can displace potassium, sodium, and calcium. These can displace hydrogen from cold water. That too here vigorously, violently. Okay, that's why these are more reactive metals. Next, here magnesium. Next, aluminum, zinc. To zinc. These three displace hydrogen from steam. Steam means hot water. Here, next iron. From iron onwards, from iron to gold. Here, these do not displace hydrogen from cold water or steam. Very important points now. So here, cold water, hydrogen can be displaced by these three metals: potassium, sodium, calcium. Here, from steam, magnesium, aluminum, and zinc. From iron onwards, there is no displacement reaction from water or steam. Is it clear? Next, in the case of cold dilute acids. Here, potassium, sodium, calcium. These can displace hydrogen from cold dilute acid. That too, that is violently. Violently means explosively. In the case of magnesium, aluminum, zinc, in these three cases, here cold dilute acids, that is vigorously. There is no explosion, but reaction is a speed. Reaction is fast only. High reactive metals, but here explosion taken place. Here reaction is vigorous reaction. Here iron can displace cold dilute acid here slowly. Iron can displace hydrogen from cold dilute acid, but not steam, but not water. Here lead can displace hot concentrated acid. Hot concentrated. From copper onwards, there is no displacement reaction. Is it clear? Remember the points? From sodium, potassium, sodium, calcium, these can displace hydrogen from cold water as well as dilute cold acids. Here magnesium, aluminum, zinc, these can displace hydrogen from steam but not cold water, and these can displace hydrogen from cold dilute acid with less reaction than these three metals. Here iron, it cannot displace hydrogen from cold water and steam, but it can displace hydrogen from cold dilute acid slowly. Here lead, it cannot displace hydrogen from steam or cold water, but not cold dilute acid also. It can displace hydrogen from hot concentrated acid only. remaining metals which are below the hydrogen, these do not displace hydrogen from cold water, steam, cold dilute acid, or hot concentrated acid also. That's why these are very less reactive metals. Is it clear? Next, third category. Third category what? Non-metal displacement reactions. We already discussed the non-metal activity series. Here fluorine, chlorine, bromine, iodine. Here fluorine can displace chlorine, bromine, and iodine. Chlorine can displace bromine and iodine. Bromine can displace iodine. But iodine does not displace any of the non-metal, fluorine, chlorine, bromine. If you observe the chemical reaction here, HBr plus chlorine gives rise to HCl plus Br2. Look at this. This is aqua solution. This is gas. This is aqua solution. This is gas. Here chlorine is more reactive than bromine. So chlorine can displace bromine from its solution, aqua solution. These are comes under non-metal displacement reactions. Is it clear? Next, another type of reactions. Those are fourth type, double decomposition reaction or double displacement reactions. Double displacement or double decomposition, both are same. The previous one what? Third category, only single displacement reaction. Look at this. Here AB plus C gives rise to AB, AC plus B. Single displacement. If you observe, AB plus CD gives rise to here AD plus BC. Observe these two. Here AB plus C gives rise to AC plus B. Means only B can displaced by C. That's it. But in this case, here B is displaced by D or C is displaced by A. Here in this case, two compounds exchange their radicals, their ions. Two compounds exchange their ions to form two new substances. Those are called double decomposition reactions. Here, double decomposition reactions are of two types. One is precipitation reaction, and second one is neutralization reactions. Precipitation reactions and neutralization reaction. Look at this precipitation reaction. Here, lead nitrate and potassium iodide gives rise to potassium nitrate and lead iodide. This is the precipitate. Look at the representation. Downward arrow represents precipitate formation. Here, this is aqua solution. This is aqua solution. This is aqua solution. This is a solid. Here, precipitate means what? It is an insoluble substance which is separated from the solution. Insoluble substance which is separated from the solution is called precipitate, and those reactions are called precipitation reactions. They're lead nitrate, potassium iodide. Here, nitrate attached to potassium and lead attached to iodine. That's why potassium nitrate, lead iodide. Precipitation reaction, double decomposition, double displacement. Similarly, neutralization reaction. Look at this. Here NaOH plus HCl gives rise to NaCl plus H2O. Look at this. Here sodium hydroxide hydrogen chloride. Here sodium combined with chlorine, hydrogen combined with hydrogen, OH combined with hydrogen, hydroxide, hydrogen, OH converted to H2O, Na with chlorine, sodium with chlorine, sodium chloride. Double decomposition reaction or double displacement reactions. So two compounds exchange their ions to form two new compounds. Then the reactions are called double decomposition reactions. And these are of two types, precipitation reactions and neutralization reaction. The insoluble substance which is separated from the solution are called precipitates. And the reactions are called precipitation reaction. Here acid plus base gives rise to salt plus water. Those are called neutralization reactions. These two comes under double decomposition reactions.